Okay, we are starting. This is section. You're not talking anymore, Nate. My turn. Section 5.3, day 3.
Let's go, Ms. White.
Yeah, let's go. All right, from yesterday, we got to that area is approximately the summation, and so we haven't done I yet. Let's do I. I equals 1 to n of f of k I x sub I delta x. Remember, we did Riemann sums originally. And we said delta x equals b minus a over n. That gives me my interval. That doesn't have an interval in it, but the delta x has the interval in it. Yes? We did that. And then we went to the actual area. If we do an infinite number of rectangles, so we're doing the limit as the number of rectangles goes to infinity, which means our delta x is going to 0. Either one of those will designate it. And it's going to be the summation, and we'll use j this time. J equals 1 to n of f of x sub j delta x. Delta x is the same. Let's talk about x now. The x sub j.
Wait, you said j, so that is j? Are you putting j back?
The J the whole time.
Oh, I did an I. Sorry, I did an I because I did an I earlier. That's a j. Sorry about that. So j. Remember, this was, if we do a right-hand sum, this is equal to a plus j delta x, right? Yes?
Yeah.
I said that we defined for a right-hand sum, the x you're going to put in to get the height of your rectangles is a plus a delta x for each rectangle you're doing. So for the first rectangle, it's going to be a plus 1 delta x. That's the x value you're going to plug in.
Okay. And then 2, and then 3.
Yes, and then 2, and then 3, and then 4. Well, now we're going to go so far as we're going to actually get all this defined. This means that if my delta x is that, then I can say that x sub j is a plus the b minus a over n times j, and then that's going to go in to there. So from that, can we go from the integral, because what's the integral? The integral is from a to b of f of x dx. That's what area equals. This definite integral matches up to that summation notation. And everything is in that x sub j that you need to pick it all out with it. Notice this is going to contain that. But I'm going to get, so this is delta x. This is f of x. So this time I'm going to, well, we'll do j for that one above, right? That I'm going to get from delta x, because my delta x is the a and b in it. And my x sub j has the a and b in it also. And that's going to be right there. So does every piece of the summation and all that information we've done, is that going to match up to the function in the integral?
Yes.
And are you going to have to go back and forth?
Yes.
Yes. They're going to give you an integral, and they're going to say, what's the summation notation? So far, it's only been multiple choice, but I'm going to make sure y'all can do it from scratch. Because on my test, it will be a free response question.
Nice.
Evil. If I'm smiling, you should worry.
It says the recording.
Yeah, it's about to go. All right. Yeah, I'm not going to worry about it. We're going to go on to the next one. I'm going to do 3 examples now. So that's the theory behind it all. It's not that much, is it? Oh, yes, it is. There's a lot of detail buried in there. That's mathematical notation, so it's really dense. Very, very dense.